I'm just throwing the weirdest questions at you, the weirdest ones that I can find. Look at this one. This one says tan x is to 2.35, and we're talking about degrees now. So we're going to have to flip our calculator back to degrees. But one thing that's very, very, very important about tan is don't forget tan has a period of 180 degrees. That's its period. So we're actually looking for the answer over 2 cycles. Well, I'm going to show you a nice little shortcut for that. That's going to be really, really pretty. All right, so don't forget that the period of 10 is 180 degrees. Okay, oof, that's important. Okay, so let's go set up our calculator. We know our calculator has to be set up between 0 and 360 degrees. So let's change our calculator around right now. So here's that last question with all that cosecant and cotangent stuff all over the place. Well, check this out. Let's clear it out. Oh, all that work just to clear that out. Let's put in our tan x here. So tan of x, bada boom, we're good. Let's go down to this guy here and put in, of course, the value we want it to be in, which was 2.35. Right? Tan x equals to 2.35. And again, we're going through a cycle of degrees here, right? Okay, so let's figure this out. This won't be so tough. We have to go into the window settings and into our mode because we're back in degrees. And look, if you look right up here, you'll notice this is saying radians. So you've got to convert this back to degrees like we wanted to. Okay, so here we go. Back into mode, over here to degrees, and I hit it. There it goes, second quit. You might even want to zoom standard this, right? Well, if you want to, okay? Let's go zoom 7. Let's go zoom trig it. Oh my goodness, that looks gross. But now put in those window settings. The window settings was from 0 to 360 degrees. Perfect. Punch it, graph it. There we go. There's our values. No, that's not so bad. Well, let's figure out that first value. Let's figure out that first intersect, which is right here. Now, remember how I said that this thing cycles every 180 degrees? Yeah, I'm going to show you something really cool right away. Let's figure out that first value. Second calc, find me that intersect 5, and we're going to mouse way over here. It's going to go off the screen, and oh, there it goes. Enter, 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 and I get 66.9 degrees, right? Okay, so let's write that answer down. 66.9 degrees. Perfect. Okay, let's go and figure out the other one. Let's figure out this guy right over here. Okay, all right, perfect. Second calc. I'm going to find my intersect, and I'm going to mouse over there now. And there it is. Enter, 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 and I get 246.9 degrees. 246.9 degrees. Wait a second. Hold a second. Hold a second. I just noticed something really, really cool. This is going to be quite interesting. Think about this. I said this was 180 degrees. What would happen if I took 66.9 and added 180 degrees to it? Surprisingly enough, if you want to go put it on a calculator, go ahead and do it, but you're going to get 246.9 degrees. Oh, why? Look back at this. Remember how I said that this actually cycles every 180 degrees? So from here to here is 90, right? Okay, that's your 90-degree increment. But if you think about it, from here all the way over to here, there's an extra 180 degrees. So this would be 90, this would be 180, this would be 270, but the distance from here to here, right, is 180 degrees. And look at that. Your entire graph, this whole blue thing, cycles between, yep, you got it. It cycles between 90 and 270, which is a 180-degree period. Oh my. That's why this number added to 180 degrees gave me the second number, because basically it's showing up on the same part of the graph. Look, I'm going to take that little part right there. I'll move it over to here and check it out. It's showing up again, which is going to show up way the heck over here another time. Look at that. There's our other part of our graph. Isn't that wild? It is so interesting to see how these guys continue to cycle over and over and over again. Lots to learn here, hey?